I'm back for round 2, geometry students. I trust you have already watched the first one, but even if you have not, you can watch them one after the other. This is the second one, and I want to take a look at some other useful review ideas here with you. Look at number 5 with me. It says if the lines A and B, here's line A and line B, are perpendicular, find X and Y at each of the 4 angles. So we're given that these two lines are perpendicular. So when you hear that, you can immediately do something like this. When you say here lines are perpendicular, you can say, you know what, that's 90 degrees, and you know this will be 90, this will be 90, and so on. So right out of the gate, you could say, you know what, X plus 2y, this angle right here, I'm going to indicate it with an arc, it's 90 degrees. That's one thing we could say. Also, this angle here is 2x minus y angle. That's going to be 90 as well. You might be saying, no, well, how am I going to find x? How am I going to find y? Because I've got a combination of x and y together. That's not the usual, like x plus 2 equals 90, where you can just find x. And that's true. There's a way of solving these two equations. It's called simultaneously. And all you need to do is to recognize that you can eliminate either the x or the y. And let's say you eliminate the y, then you only have an equation in x. And you say, well, how do you do that? Well, listen carefully now, because you've done it in Algebra 1, or you could have. What you can do is you can multiply this negative y by 2. And that would give you negative 2y, such that when you add this equation with this one, you have a positive 2y and a negative 2y here, and that will eliminate the y's. But here's the way you have to do it. And I hope I can get another color in here to show it. Let's try this. We have to multiply this side by 2. That's the right side of the equation. And when we do that, then we also have to multiply this side by 2 as well. Okay, where can I put it? 2 here. So we're going to kind of do the backward distributing. And here's what we'd get. We get 2 times 2x would give us 4x. And 2 times negative y would give us negative 2y. That's really what we're after. Because we want to do positive 2y minus 2y so we can get rid of the y's. But we've multiplied the left side by 2. Let's do it on the right side now. It's equal to 2 times 90, which is 180. So that's what this second equation becomes when we multiply the left by 2 and the right by 2. And we're allowed to do that as long as we do the same on the left as we do on the right. That's permissible. So that's what this equation becomes. We will leave the first one untouched. So let's see if I can go back. So the first one will remain x plus 2y equals 90. That's this first equation here. So now we're going to add these two together, and we're allowed to do that. When we add, we get 4x plus x is 5x. Negative 2y plus y is nothing. And over here, it will be just adding here as well. 9 plus 8 is 17. 0 plus 0 is 0. Carry the 1 from 17, and 1 plus 1 is 2. So we have 5x equals 270, and that's the way we find the x. So we divide both sides by 5. You can do it off to the side if you like. Maybe like here, 270 divided by 5. 5 times 5 is 25. Subtract 7, take away 5 is 2. Bring down the 0. 5 goes into 24 times. 4 times 5 is 20. So we have x equal to 54. And no more. Alright, so that would give us the x. And once we found the x, you could actually go in and find the y. You could use this equation or this one to find the y. Alright? So you said, oh, what do you mean? We plug the x in here, right in here. So using this equation, see if I can bring it down here. Instead of x, I would write 54. And then plus 2y equals 90. And that's the way you'd be able to find the y. Subtract 54 from both sides. When you do, you get 2y is equal to 90, take away 54 will be 16. Is it? Not quite. No, it's 26. Well, let me see. 90 take away 50 is going to be 40. And so this should be 36. Okay, you can check it. Divide by 2 now. And we get 2's canceling out, y is going to be equal to 18. Okay, so that's the way we do it when we have these being perpendicular. And what it means is that these two angles marked with the arc, this angle is 90, this angle is 90. So these two angles, 2x minus y and x plus 2y, they're not only right angles or righteous angles, but they are also supplementary. Okay, and yeah, that's how you'd find the x and the y. How about another look? Let's take a look at what we've got over here. What can we find with the information given below? Here we've got similar to what we just have, but it doesn't tell us that these lines are perpendicular, A and B. But we can't find x though. So how can we find x? Well, this angle here that I'm going to mark with the arc is 5x, and this other one is 7x minus 30. How can I find the x? I trust I hear somebody shouting, vertical angles, vertical angles. Exactly what, right. And vertical angles are always what? Always equal. So 7x minus 30 equals 5x. And so we can do it a couple ways. We can subtract 5x from both sides. So that would give me 7x take away 5x is 2x equals 0. And I'm going to add the 30 to both sides. When I do, I get 2x equals 30. Adding 30 to both sides, because the 30 would cancel from the left. Divide both sides by 2. 30 divided by 2 is what? 15. Okay. So that's how we'd find the x there. And once we found the x, we can actually plug it in here to find this angle. That would be 5 times 15, which would be 75. And what would this angle be? Oh, you know it's going to be the same, 75. And since these are intersecting lines, let's say this is 5 times 15, 75 degrees. This is 75 degrees. Could we find angle 1 and angle 2? I'm sure you know, yes, we could. Because this whole thing here, this whole angle, is how many degrees? 180. Okay, just like how the sun governs by 180 degrees the day. So this angle here would be nothing more than 180. Measure of angle 1 would be 180. Take away 75. So we subtract, we get borrow 1 here. 10 take away 5 is 5. 7 take away 7 is 0. 105 degrees. Okay, and we could find angle 2. What would 2 be? Well, if this is 105, then this has to be what? 105. Okay. All right, let's take a look at a couple more topics that would be helpful. Let's say we've got two lines X and Y, intersected by T, which would be the transversal again. I'm sure you know it's line T, transversal. Now, classification of angles, which would be our, let's say, alternate interior angles. Those would be angles 4 and angle 5, or we could say angle 3 and angle 6, alternate interior angles. Yes. How about our alternate exterior angles? That would be angle 1 and angle 8. Also, angle 2 would be alternate exterior with angle 7. Okay? Maybe the easiest one would be corresponding angles. Corresponding would be top right with top right 2 and 6. Or we could take bottom right, corresponding, and also on the other side. So those would be simple. But now, how about same side interior angles? Same side interior angles would be angle 4 with angle 6, or angle 3 with angle 5. Now, which angles would have to be congruent in order for lines X and Y to be parallel? Well, corresponding angles like 1 and 6, or angle 4 and angle 8. If those are congruent, that would force lines X and Y to be parallel. What else? Which angles? Which other angles? How about alternate exterior angles? Yes, if 1 and 8 are congruent, that would force lines X and Y to be parallel. Or if angles 2 and 7 are congruent, those are alternate exterior angles that would force lines X and Y to be congruent. That would be alternate exterior angles. Corresponding angles, alternate exterior angles, but there's more. How about these angles here, angle 6 and angle 4? What would have to be the relationship between these two in order for X and Y to be parallel? I hope you're saying it. Angle 4 and angle 6 would have to be supplementary. Say it with me, same side sub. Same side sub. If they're supplementary, then lines X and Y would be parallel. Okay? That's a review on those classifications. And finally, let's take a look at slopes of parallel lines. Let's say we have we got line J here, line E, and line S. Let's say line E is parallel to line S. You have to look for your arrows. If they're parallel, then they have what? The same slope. So say that with me. Parallel lines have the same slope. Okay? So parallel lines have the same slope. So for example, if the slope of line E is equal to, let's say, 3/4, then what would be the slope of line S, which is parallel? Same thing. Slope of line S would have to be 3/4. But now, somewhat different. Perpendicular lines, if this is perpendicular, then the perpendicular line would have a different slope. It would be the negative reciprocal, -4/4.